Alright, welcome to week 21 maintenance Pure Maths 1 students. First question, quadratics. We've got a rectangle, side length x and then 3x minus 2. We know the area is 63, we've got to find the value of x. So obviously we're just going to go x into 3x minus 2 is equal to 63. We'll expand the bracket so we get 3x squared minus 2x minus 63 equals 0. I've just brought that 63 across to one side. And then, I think I'll just use the quadratic formula here. So it'll be x equals minus 2 plus or minus the square root of minus 2 squared minus 4 times 3 times negative 63 all over 2 times 3. And this is giving me two results. But I'm going to take the positive result, and that is 4.928. Okay, next one. We are trying to express this this function in this form here. So we're completing the square. I'll take that 2 out first, and so I'll have in my square brackets x squared minus 4x, and I'll keep this plus 5 separate. Then within the square brackets I'll complete the square, so it'll be x minus 2. I've halved that 4. I square that, then I take away the minus 2 squared, which is 4. Close my square bracket, plus 5. And this will give me 2 bracket x minus 2 all squared minus 8 plus 5. And we can write that as 2 into x minus 2 all squared minus 3. And that's my final answer. Now, the next one is asking me to state the value of k for which the graph of y equals fx has a line of symmetry. So you can see I've just done I can find my minimum point by looking at the value that x would have to be to make that bracket equal to 0. So it's 2, and then the y value would be minus 3. So we know that that's this minimum point here, and we know that this is for 0 is less than x is less than or equal to k. So we're looking at a particular part of the function here. So coming along from x equals 0 all the way to k, and we want a line of symmetry. So if we want a line of symmetry, we want to come across the other side. So you can see if this is 0 here, and we want a line of symmetry which runs through here. Obviously we want to go to 4 on the other side, I think. So I'll say k equals 4. Now the range will therefore be, your lowest value is here, and all we need to do is pop in either 0 or 4 into the equation, and we will get, so I'm popping it into here, and 0 is obviously easiest, so we just get 5. So this is 0, 5, and this should be 4, 5 as well. Well, let me just check that. So it'll be 2 times 16 equals minus 32 plus 5. Yep. Okay, cool. So we know that our range is between negative 3 is less than or equal to fx is less than or equal to 5. And I think that's what we want there. Okay, the coordinate geometry question. We've got to find the equation of a circle that touches the x-axis and whose center is at 6 minus 5. I'm assuming if it just touches the x-axis, so we've got a center here, 6, minus 5. If it just touches the x-axis at one point, which is what I'm assuming this is saying, you know that your radius must therefore be equal to 5. So I would write this as x minus 6 all squared plus y plus 5 all squared equals, then I think it should be 25. because if it touches the x-axis, then it's got to go up 5 from that centre. Okay, so that would be my answer there. Okay, what else have we got? Moving on to the next page, we've got circular measure. So the diagram shows a sector OAB of a circle, and what are we trying to do? Sorry, there's a lot of background noise in my household. I've got so many noisy kids at the moment. The diagram shows a sector OAB of a circle with centre O and radius R. Angle AOB is theta radians. The point on C, the point C on OA is such that BC is perpendicular. Okay, right, yep, fine. And the point D is on BC. Yes, I can see that. And the circular arc AD has a centre C. And we've got to find AC in terms of R theta. Okay, well, hopefully we can see that AC is equal to CD, and we know that CD is equal to half of BC. And we know that sine theta is equal to BC over R. Okay, so I'm considering this triangle here now. So sine opposite over hypotenuse, that's what we're doing there. And then we can say that BC equals R sine theta, and so AC is equal to half R sine theta. So now I need to find the perimeter of the shaded region, so I'm going to find arc DA first, and that's this bit here. And arc DA is R theta, and R theta, we know that R is equal to, or the radius here, so it's so R theta, or the radius of the circle that we're dealing with, is the way you find the arc length, but R in this case is CA, or AC, which we've found up here. So that is our R in this case. So it's going to be half R sine theta times theta. Then we've got arc BA, which is this one, all the way around here. And again, that's R theta, but this time it's just R theta, because this is our R here, right, and that's our theta, so that's fine. Oh, whoops. Now that just made me realize that I made a mistake in the previous one, because theta in the first one is not just the theta radians that we've got here, it's actually this pi over 2 that we've got here, so I'm just going to replace it with pi over 2. Wake up. And then of course we've got dB, and dB equals to half R sine theta, which is because it's equal to AC, and DC is D is the midpoint of CB. So we're just going to add all of these together. Now, when we add them all together, we should get, let's have a look, let's put this into rounds. So we would have 4 over 3 for this first bit, because half times 4. Sorry, my mistake. Half times 4 for our radius is 2. So we get 2 times sine theta. Now sine times pi over 3 is square root 3 over 2. And then we've got times pi over 2. Then we're going to add to that r. So that's 4 times theta. What did we say theta was? Pi over 3. And then we're going to go half times, so for dB, we're going to go half times 4, which is 2, times sine theta, so sine pi over 3, which is square root 3 over 2. And cancel, cancel. So what are we going to get? Cancel, cancel. We'll get square root 3 pi over 2 plus 4 pi over 3 plus square root 3. I guess we could add those together, simplify it. So 4 pi over 3 plus square root 3 pi over 2 will give us, what will that give us? I guess we could make them into sixths. So we'll make it into sixths. That will be 3 square root 3 pi plus 8 pi plus square root 3. Honestly, I'd be inclined to probably just leave it as this. Alright, next one. We've got this equation. We want to turn everything into sines. I'm going to use my identity here to make this 2 into 1 minus sine squared x equals 3 sine x. So remember what I've told you in class. We always want to, with our trigonometry, we always want to make sure that we get everything into sines or cosines. So that's why I know how to turn a cosine squared into a sine squared. Now I'm going to bring everything across to the right hand side. So I get 2 sine squared x plus 3 sine x minus 2 equals 0. Sorry about the vacuum cleaner in the background. So I'll get 2 sine x minus 1 into sine x plus 2 equals 0. And so I'm going to get sine x equals 1/2, or sine x equals -2. Well, there's no real values for that one, so we can ignore that. So we get x equals the inverse sine of 1/2. And now, what do we get for that? Well, we get x is equal to 30 degrees. Now, since we're looking at values between 0 and 360, if I've got one at 30, and this is 90 here, this is 180 here, you know that we've got another one here, which is 180 minus 30, so it should be 150 degrees. Alright, next one, we've got to do a series question. First 3 terms of the expansion. Okay, that's pretty easy. So the first one is 6, choose 0 times 2x to the power of 6 into negative x squared to the power of 0. The next term is 6, choose 1, 2x to the power of 5 into negative x squared to the power of 1, plus the next one is 6, choose 2 into 2x to the power of 4 into negative x squared to the power of 2. Now when we put this all together, we're going to get 64x to the power of 6 for that first term. The next one, because we're going to have a negative, so it'll be negative. Now 6 times 32, so it'll be negative 192. X to the power of now 5, take away 2, so it should be 3. Oh, sorry, no. Not take away 2, it's not a negative power. It's a positive power. It's just a negative coefficient, so this should be 5, 6, 7. I think it should be 7. And the next one is going to be a positive, so it's 6 choose 2 times by 16, I think. So it should be 240? 2 to the power of 4, 16 times 6 choose 2. Yeah, I think it should be 240. So we'll go 240. And what else can we say here? 240 should be x to the power of 8. I think it should be x to the power of 8. Cool. And it says hence find, so using what we've done, find the expansion for x, what the heck? Coefficient of x to the power of 8 in the expansion. Okay, so we're going to go 2 plus x into, and then we'll just use what we've already got, right? We've got this. Like that. And you can see that the ways that we can make this x to the power of 8 up are, we could multiply this by this. Or we can multiply this one by this one. In which case we're going to get 240 minus 192 are our, will be the coefficients. So this will give us 48. Okay, now we're going on to an arithmetic progression, and it's the first term of an arithmetic progression is 61, and the second is 57. Sum of the first n terms is n. Find the value of the positive integer. Okay. First term of an arithmetic progression is 61, so we say a is 61. We know the second term is 57, so therefore d is equal to negative 4. And we want to know the sum of the first n terms. Sum n, and we know that that is this, n over 2 into 2a plus n minus 1 into d. And we know in this case it is equal to n, so now we can find out what n is. So let's go ahead and work that out. Now, we don't know what n is. I'm going to times both sides by 2. So on this side I'll have 2n. Then I'm going to put in my values here. So 61, 2 times 61, which is 122, plus n minus 1d, n minus 1 into negative 4. And then I've got my big bracket at the end. We'll just put this in here. Okay, so I get n into 122 minus 4n, minus 4n plus 4 equals 2n. And I could divide both sides by n. And then I could go 126, 124 equals 4n. And therefore n equals 31. And that would be my answer. So let me see. 31. Okay, so the next one, we've got a curve of this equation here. We've got to verify that the curve has a stationary point at x equals 2. So first of all, I'm going to write y equals 2x plus, and I'm going to go x minus 1 all to the power of negative 2, and then I'm going to do dy dx for my gradient function. I'll get 2 plus, and then I'll take this one, I'll times it by the coefficient of the x, which is 1, so negative 2, then I'm going to drop my power down by 1. So I think my dy dx is 2 minus 2 over x minus 3 all cubed. So let me see, I'll just fix that up. X minus 1 all cubed. Okay, there we go. Now, to verify, I've got to see that at x equals 2, it should equal to 0. So 2 minus 2 over 0 minus 1. Oh, that should be cubed, shouldn't it? 0 minus 1 cubed. Oh, sorry, my mistake, not 0, 2. And then this should be equal to 0. So the gradient function should equal 0 at the stationary point. Now we get 2 minus 2 over 1 cubed equals 0. Yes. So there is a stationary point. Now, how do we determine its nature? There's a couple of ways of doing this. We can do the second derivative, which is what I'm going to do. So this 2 is going to drop out. I've got... so I'm just going to write dy dx over here again just to show you what it will look like. So I've got a 2 minus 2, and then I'm going to write it as minus x minus 1 into negative to the power of negative 3. So I'll take that negative 3, I'll times it by the coefficient of the x and times it by the negative 2, so I get positive 6. And then I will end up with x minus 1 to the negative 4. At x equals 2, the second derivative equals 6 into 2 minus 1 to the power of negative 4 equals 6 over 1 equals 6. And therefore, because since the second derivative is positive, we know we have a minimum point. Okie dokie. Well, I hope there is enough information for you here, and I hope I haven't made mistakes. I've been a bit distracted with the noise in the background this morning, so let me know if there are any issues and I can fix them up for you. If you've got any questions, of course, let me know as well. Alright, take care.